Okay, one type of visual that we can use and organize our ratios is called ratio tables. So the vocabulary, and a lot of this we've already talked about. Ratio table organizes data into columns that are filled with pairs of numbers that have the same ratio or are equivalent. Equivalent ratios express the same relationship between two quantities, and then scaling is either multiplying or dividing, and we've talked about how multiplying is going to be multiplying by a whole number if we want to make it bigger. If we want to make it smaller, we can also multiply by that fraction. But doing that to two quantities by the same number, you may need to scale back, okay, go backwards or either go forwards to find the equivalent ratio. So we've been talking about that as a scale factor. And a scale factor is the number that you multiply by to increase, or if you want to make a number smaller, multiply by that fraction. So on the first one, it says example 1, you need 1 cup of rolled oats. So we have 1 cup of rolled oats to make 24 oatmeal cookies. Use the ratio table to find out how many oatmeal cookies you're going to make with 5 cups of rolled oats. So it starts pretty simple, where we have a ratio of 1 to 24. And I don't know that in the real life situation I would use this kind of table, because I don't really need to know these with this given ratio. I could just multiply 1 by 5 to get 5 and 24 times 5 to get the missing number. But with this here, I can see there are 3 numbers missing. That would be 2, 3, and 4. And I can see that my cups are going up by 1 to 2 to 3 to 4 to 5. I'm adding 1 every time. But if I double the recipe, okay, then I'm going to double the amount of oatmeal cookies that are made. And so for that, I would get, with 2 cups of oats, I would get 48 cookies. I could add 24 to this as well and get 72. And then add 24 more to get 96. And then 24 more would give me 120. Now, if I wanted to find 9 cups of oats, how many cookies I could get, I don't want to have to find 6, 7, and 8. I would then say, you know what? I can take 1, multiply it by 9 to get 9. I could take 24 times 9, 6, 3, 8, and get 216. So I could do that to find the number of cookies. I could just find that equivalent ratio by multiplying both parts by the same thing, okay? Now, this is where, and so it says 120. You can make 120 cookies with 5 cups of oats. For the next one, it says a department store has socks on sale, and you get 4 pair of socks for $10. Use the ratio to find 6 pair of socks. So notice that information has been filled in, but not as easy this time. If I have 4, I cannot change it to 6 with multiplication or even division. That's not going to work. So I need to change this to a number that I can work with to get this. So if I take and divide both of these by 2, I can get a 2 to 5. Okay, so that is equivalent. So for 2 pair of socks, it would be $5. If I wanted 6 pair of socks, I could change the 2 times 3. I would do the same thing here, times 3, and I would have $15 for those 6 pair of socks. So I want to find that multiplicative relationship so I can find the parts that are missing. So it says in this case, we had to scale back. We had to make it smaller before we could go up. And to do that, we found that the GCF of 4 and 10 was 2, and that's what we divided by so that we could simplify the ratio and then scale up or multiply by 3 to find our answer. Example 3 says a dog shelter has a 24-pound bag of dog food. It's going to feed 36 dogs a day. How many dogs would you expect to feed with a 16-pound bag of dog food? Fill in the ratio table. So this time the numbers aren't filled in, but I do have pounds of dog food, so that's going to be a 24. And with the 24, I can feed 36. I'm always going to put at the end what it is I'm trying to get to. So 16 pounds is going to go here. Okay, this at the bottom is going to be the number of dogs. Well, I cannot change 24 to 16, but I could divide to make it smaller. And whatever I get, I want it to be a number that's compatible with 16 that I can multiply by. So I could divide both of these by 2, but I can't take 12 and change it to 16. If I divided, for example, by 6, oh, I could. If I did 6, I could divide this by 6 and I could divide this by 6, and this would give me a 4 and a 6. And I could then change that 4 to 16 by multiplying this by 4. So then if I multiply this by 4, I would get 24. Now, I also see that for both of these, I could divide them both by 12. If I divided by 12, I would get the 2 to 3. I would just multiply by a different number. I would still get 24 for my answer. So there's more than one way to get the answer as long as I am keeping everything balanced, either multiplying or dividing by the same number. It's still going to work out. All right, Mr. Fink's economy car can travel 420 miles on a 12-gallon tank of gas. So we have 420 miles and we have 12 gallons of gas that are used. Use the ratio table to determine how far he can go on 8 gallons of gas. So if I fill in my information, miles is 420 and it's a 12-gallon tank. And I have to figure out what I can get with 8 gallons. Well, I can't change 12 to 8. So I want to think of a number I can divide by so that I could multiply to get 8. 12 may go into 420. I think, though, to think easier, I could divide both of these by 6. Because if I divided by 6, this would be a 2, and that would work. 6 will definitely go into 42 7 times, so that would be 70. If I divided by 6, this would be a 2. So both of these are dividing by 6. And if I have 2 to 8, it's going to be times 4. If I do the same thing here, times 4 is going to be 400. If I multiply by 4, it's going to be 280. Okay, so we have 280. All right, for the next one, it says an ostrich can run at a rate of 50 miles, and that is in 60 minutes. At this rate, how long would it take an ostrich to run 18 miles? So we have a distance of 50. The time it takes is 60, and we're trying to figure out 18. We're going to put that at the end so that we can have the end result that we're looking for. So if we have 18 here, this is pretty tough because I have 50 and I have 60. And I cannot think of a number that I could multiply by that is going to give me that 18 because that's 2 times 9 and there's no factor of 3 or 9 in this. The 2 would work, but I'm not going to be able to get that. So I'm going to simplify by dividing by 10 and I get 5 to 6, okay? I don't know the number that 5 times what is 18, but I've got to figure it out to get the time. So I know that I'm going to multiply by something. To find that, I'm going to take 5 and see how many times it goes into 18. 5 goes into 18 3 whole times, and that's going to be 15. When I subtract, I get 3. I'm going to add a decimal, bring down a 0, and 5 goes into 36 times. So I can see that 5 times 3 and 6/10 is going to give me that 18. I'm going to do the same thing here to get the answer. So I'm going to take 3 and 6/10 times 6. 6, 3, 18, 19, 20, 21. I have one number behind the decimal, one behind the decimal. It's going to be 21 and 6/10.